Hello, Mr. Greg here, and welcome to Lesson 9, Part 2 of our DC motor project. If you remember correctly, we left off with, we had just put our DC motor on the breadboard, and now what we need to do is get all of this connected up. So we want to run our DC motor, and we're going to use our separate power supply to do that. But if you know, a DC motor can run in two directions. It can run in clockwise or counterclockwise directions. And so we want to be able to move our motor in either direction depending on what our desire is. And so to do that, you have to set up a couple of switches like this. So, for example, if we wanted our motor to run in the clockwise direction, then we would need to connect this switch and this switch, and then the current would flow through our circuit, through the motor. It would turn the motor just like we talked about before, and then come back and go to ground. And then if we wanted to reverse, then we would undo these switches and connect these two switches this way. And then the current would run through this switch through the motor. It would turn it in this direction and then back to ground. And our motor would turn in the opposite direction. Now we could install 4 switches on our breadboard, and as we pushed these two, our run, and if we push these two, our motor would run this direction. But that really seems like a cumbersome type activity. Plus, in the future, we might want our motor to run based on different inputs. Maybe if it was a fan motor, how based on the temperature. Just like a thermostat would work. Or maybe if we hook this to our robot, then we would want the input to be based on where we positioned a joystick. And so even though this would work, it's not really a very practical setup. And so rather than use multiple switches, what we would like to use is what we call transistors. Now this is a couple of transistors that I have, and basically let me get these out. Transistors come in a lot of different sizes and types. There's NPN transistors and PNP transistors here, and they have different functionalities, but they're basically all have the same form factor. They have a flat side and a round side, so you can tell which is the emitter and which is the and which is the collector. And so I have a couple of them hooked up here. This is what is known as a Darlington transistor setup, where I have the emitter of one of the transistors going into the base of another transistor. I didn't mention the middle pin is the base. And so the way this works, simply put, is that 0.7 volt signal going to the base, you can see that, going to the base of the transistor allows current to flow from the collector to the emitter. And so basically this acts as a electrical switch. So just a small amount of voltage going into the base can turn on a larger amount of voltage through the collector and emitter. And then if you put them in this Darlington setup like this, then you actually get some amplification on it. And so we could hook our motor up this way and use a whole bunch of transistors, but that would take up space, because also we've got to put some resistors in here, and maybe a couple of gates, maybe like a NAND gate, which we'll discuss sometime in the future. And before long, I'll have this whole board filled up with components just to run our motor. Well, there's an easier way of doing this, and fortunately our kit contains that easier way, and it's called a motor controller. And so I need you to get out this circuit in your system, and on it, it has what is known as an L293D label. And there's no way you'll see that on this camera, but you can look in your kit and you will see the L293D circuit. And this tiny circuit contains all of these transistors, resistors, and everything that we need to not only hook up one motor, but two motors. Now, we're only going to hook up one today, but we could actually control two motors from this tiny little circuit. And that's all these circuits are just miniaturized components put in such a brilliant way that we can use them for different things. And so this circuit is divided up into several different components, which I want to show you now. So I'm going to get that out. So if we were able to look inside of this circuit, we would notice that each of these pins represent a different output or input for our motor controller. And the way these pins are always labeled 1, 2, 3, 4, all the way through 16 pins, and typically from left around to here, across C9, and then back up to here. Now, how you know which way this is oriented is based on a little half circle or notch that's on one end of the circuit. And I doubt you can see that in this, but you should be able to see it on your circuit. And you can see the notch is illustrated on here. And so we want to make sure we understand which way we're applying that and what each of these outputs mean. And so let's get this hooked up. So I'm going to go ahead and put my circuit in my breadboard, and I'm going to put it across this valley here so that I can differentiate my connections. So I'm just going to put that about right here, and my notch is oriented to the left towards the circuit. And so I want to go ahead and hook up these wires, and I'm going to do that based on a diagram that I have made. Let's see if you can see that. There it is. And so here's the hookup, because I know sometimes I go fast and it's hard for you to follow. So we've got our power source, and one thing you got to remember when you've got a lot of different components like this is that you have to always keep your grounds hooked together. So you want to make sure all your grounds are hooked together. And a common mistake is not to ground your Arduino with the ground of your power supply. And so I don't forget that. I'm going to do that first. So I'm going to take a black wire and I'm going to hook that into the ground like that. All right, the next thing I want to do is look at my diagram and see what pin 2 is, and that's an input pin. So that tells me that we're going to need to hook that to the Arduino, because it's going to look for a input. So I'm just going to use a red wire, short red wire for that. And again, I'm hooking up pin number 1 to pin number, what is on there? 11. Alright, and then on my second pin, I'm going to hook pin number 10 to pin number 2 of my output. Just like that. Alright, and then on the third pin on the circuit goes to the red wire of your motor. So I'm going to hook that up, making sure I get this right. 1, 2, 3 to the third pin of the circuit, like that. Again, I'm just following the diagram. So the fourth and fifth pins of our circuit are pins, as you can see here. So I'm not going to need both ground pins, but I will need one. And so I'm going to hook my fourth pin to a ground pin. Because I'm out of black wires, I'm going to use a green wire on that. Now I've created this ground rail, and I'm just going to hook that there. I'm going to skip pin number 5, and pin number 6 is an output pin, and so I'm going to hook my black wire there. So this is not a ground wire, this is an output wire. So this completes the circuit through my, about to mess up here. Oh, I did mess up. That goes there, that goes there. So again, I'm just following the diagram. If you get behind, just pause the video a little bit. All right, so the final pin is the input. So this would be the one that actually reverses the direction. And you can see I have it illustrated with the yellow wire. And I'm going to hook that to pin number 9. Pin number 9. Here. And then my final pin on my illustration is my voltage input to the motor. And I'm just going to hook that final pin here to my positive rail here. Just like that. So I believe I have that hooked up correctly. So now I'm going to open up my Arduino Ide so that you can see that. We'll close this and open that up, and we can start getting some coding done. Okay, we have our nice new open Arduino sketch ready for us to get started. I'm going to give him some space because we have some pins that we've hooked up, and so we need to establish some variables. So let's think about this. We want to speed of this, and so I probably need to have a speed pin. So I'm going to type that in, integer speed, and we actually hooked that to pin number 11. So that's going to help us change our speed. And then we've got a direction, actually 2 directions. So I'm going to say we got direction 1 and we hooked that to pin number 10, if you remember correctly. And then direction 2, we hooked that to pin number 9 on the Arduino I'm talking about. And then we want motor speed, so I'm going to call that M speed. And that speed, we'll just go full blast, 255. Just like with the LED, 255 is the high point. All right. So the next thing, it's always good to just go ahead and turn on your serial monitor. So I'm going to go serial.begin. Good old 9600. And then I'm going to, we have pins, so we got pin mode. Our first pin was the speed pin. And I'm going to set that as an output. And we got pin mode. We've got our direction, our first direction pin. Oops, and that's an output. Oh, I see I spelled pin mode wrong. Direction 2 is an output. I hope you understand why these are outputs and not inputs, because we're actually making them, they're going out from the Arduino. If you don't understand, leave a comment, give me a call. All right, our M speed is just a variable, it's not a pin, so that looks pretty good there. So I'm going to go down to the void loop, and I'm not putting my comments in here because I don't want to bore you with putting those in here, but you need to put them in when you turn them in. So what am I going to do here? I want to move the motor, right? Let's see if I can change our view. So I want to be able to turn the motor, which means I just want to turn it. So I'm going to come back to our code here, and I'm going to say digital write. I'm on digital write pin 1, and I'm going to turn it high. That's got to be capital high. So basically I'm turning it on high. So if I turn the pin 1 direction high, then I need my direction 2 to be low, because if I send high directions, if I turn both directions on high, then the motor will be running against itself. I hope that makes sense. So I turn one direction high, and then I'll turn second direction low, and then that'll turn the motor. Digital write direction 2 low. Oops, get too fast. And then, so now I'm telling my DR1 pin to go high and my DR2 pin to go low or to be turned off. So now all I got to do is tell it what speed to run. And so we want that speed to vary. And if you remember, we set up a variable up here called M speed. So I'm going to do an analog write, and I'm going to write that to my speed pin. Again, set up here, speed pin to 11, which goes into our circuit, and I want to write what value? My M speed. So then we could write that to the serial print. I'm just going to serial print M speed. I'm going to make that an LN. In case I have an issue, I can go in and look at my serial monitor. So there, now let's see if it downloads. I do not want to save. It's looking good, looking good, looking good. Let's change to this. Seems to have worked. So if I push my on off button here, look at there, we get rotation. Now if I wanted to change the speed of my motor, I could come back here to the M speed and I could type in a different number. I'm typing in 150 and I could download that. I'm just gonna now we're running at a slower speed, 150. All right, so let's see if it'll run at 100. Let's download that. Look at there, even slower. I wonder how low. I'm gonna go put in 50. Let's see if it'll run at 50. I wish it would quit asking me that. Nope, nope. It does not like 50. Let's do 80. My motor is screaming. Yep, we could run at 80. So that is very interesting indeed. Let's go back to 255. You can have fun with this. And there we go. So now that we've learned to do this, there's a lot of possibilities. I think in our next lesson, we're going to see if we can hook up the joystick and control the motor speed. So what I want you to do now is write a program and control the motor speed, but I want you to change, using if statements, change the direction that the motor runs. So using your if statements, if you put a value of a certain amount in there, it runs in one direction, and if you put another value, it runs in a different direction. And then see how low it can go. And that is due next Tuesday. So I hope you have a great day, and I'll talk to you later.